How many numbers would you need to describe the moon? Thousands, maybe millions. Every crater, every ridge, every chemical. Each one needs coordinates, measurements, data. Now think about a black hole, the most massive, most violent object in the entire universe. The answer is 3. Mass, charge, spin. That's it. That's everything. An object that could have formed from a collapsing star, or a billion years of swallowed gas, or every piece of information ever written by every civilization in the universe, reduced to 3 numbers. So the question is, where did everything else go?
1780s, rural England. A country priest with too much time and too sharp a mind. His name is John Michell. Newton had already said 2 things. Gravity pulls everything, and light is made of particles. Michell asked the question no one else dared. What if gravity pulls light too? He already knew light had a speed, 180,000 miles per second. Fast, but not infinite. He already knew objects fall back down unless thrown fast enough to escape. So what if a body were so dense that even light couldn't get out? He wrote it down, published it. The world ignored him for 150 years.
A German astronomer named Karl Schwarzschild is surrounded by mud and death. To escape, even for a few hours, he picks up Einstein's brand new equations and starts solving them. Einstein believed no one would ever find an exact solution. Schwarzschild found one in weeks. And buried inside it was something strange, a critical radius where the mathematics broke down, a boundary. Cross it, and you cannot come back, not even light. The event horizon. Schwarzschild sent his solution to Einstein from the trenches. Months later, he was dead, but his equation survived.
Your face is unique. To describe it completely, every pore, every asymmetry, would take an enormous amount of information. A black hole has none of that. It doesn't matter if it formed from a dying star or swallowed gas for billions of years, or absorbed the entire contents of a civilization's worth of knowledge. Once formed, it remembers nothing. Physicists call this black holes have no hair. Mass, charge, spin, everything else, every detail of its origin, its history, its contents, erased. Or is it? Stephen Hawking is in his 20s, just diagnosed with a disease that will kill him in 18 months. Instead of stopping, he starts. His advisor, John Wheeler, is having tea. He mixes hot tea with cold. Entropy increases. Standard physics. Then he asks, what if this cup fell into a black hole? The tea disappears. The entropy disappears. One of the most sacred laws in physics violated. That bothered a student named Jacob Bekenstein, and it led him somewhere radical. Black holes must have entropy. And if they have entropy, they have temperature. Not metaphorically, not mathematically. A real temperature. The same kind you'd measure in an oven. Hawking proved it. And that created a problem. Hot things radiate. Place your hand near a fire, you feel it without touching. So if a black hole has temperature, it must be radiating something. But nothing escapes a black hole. The answer lies in quantum mechanics.
empty space isn't really empty. At the quantum level, the vacuum constantly flickers, particle-antiparticle pairs blinking in and out of existence. Right at the edge of the horizon, sometimes one particle falls in, the other escapes. The black hole pays the debt, loses a tiny bit of mass. One photon gets out. Multiply this across billions of years, and the black hole slowly, imperceptibly evaporates. Hawking radiation. Black holes are not black. They glow, faintly, almost invisibly, but they glow.
Now comes the problem that kept physicists awake for decades. Imagine everything ever known, every book, every memory, every piece of data falling into a black hole. The black hole evaporates. The radiation it emits is featureless, random. It contains no information. So where did everything go? In quantum mechanics, information cannot be destroyed, ever. It can be scrambled, hidden, but never erased. But Hawking's calculation said it was gone. One of them had to be wrong. This became the information paradox, and it split physicists for 20 years.
The answer came from something Bekenstein had noticed. For a gas, entropy grows with volume. The bigger the space, the more possible configurations. But for a black hole, entropy grows with area, the surface, the horizon, not the inside, the outside edge. This was the first whisper of something extraordinary. The holographic principle. Everything happening inside a black hole, all the information, all the physics, all the history, is encoded on its two-dimensional surface, like a hologram, like a shadow on a wall that contains the full three-dimensional image. The information doesn't disappear. It lives on the boundary. And this idea may be the bridge between gravity and quantum mechanics, the two great theories of the universe that have never been reconciled. Black holes might be the key.
Almost 300 years ago, a country priest asked what would happen if gravity trapped light. A century later, a dying soldier solved Einstein's equations in a trench and found the event horizon. 50 years after that, a young man given 18 months to live discovered that black holes glow, evaporate, and that everything we thought we knew might be wrong. And today, we still don't have all the answers. But here is what we know. The most violent, most massive objects in the universe, objects that devour stars, bend space-time, swallow entire histories, can be completely described by 3 numbers. And somewhere in those 3 numbers, somehow, everything that ever fell in is still there, waiting.